So in this example, we're going to do something really interesting with geometry. You're going to use some geometry equations to actually do something called maximizing, which of course maximum is going to use the vertex equation. But let's look at the setup. So we're going to bound a rectangle by the x and y axis. So my graph is only x and y axis, and the line 4 minus 1/2 x. Now, a lot of times on the AP, they write your y equals mx plus b equation backwards. Why do they do this? They just do. So this is my rate of change, and this is my y-intercept. So if I'm going to graph this, I'm going to start at 4, and I'm going to go down with a rate of down 1 over 2. Down 1 over 2. And I'm just going to fill up the graph as much as I can, down 1 over 2. Okay? And that's going to produce a constraint upon the rectangle being graphed. Okay. Now that graph right there, basically think of the y-axis and the x-axis as forming a constraint size. Like think of this as maybe a room, or think of this as a roof line in a house. And I now want to find a rectangle that is bounded by this. Now the rectangle is just a regular old rectangle, right? It could be multiple locations though. So I could have a rectangle here, right? I could have a rectangle here. I could have a rectangle here. Okay? I don't know which one it is because I want to find the one that produces the maximum area. Again, a great example of this is I'm building a house and I want to put the biggest room I can to maximize my materials. So I'm going to just look at one of them with you. I'll just look at this one to help us model it. Well, the area of a rectangle is very easy to understand. It is length. By the way, this is a cursive L. If I use this, it might look like a 1. So cursive L times width. And the length, it doesn't matter which way you do this. Maybe it would make more sense instead of saying I said width, I said height. Maybe that'll make more sense. The length is down here, and the height is here. Okay, so hopefully we're making pretty good sense. Again, this is a cursive L. Well, the length in this case is the given x value. So I'm going to update my equation to be that the area, and it's going to come out, we'll see what it comes out to in a second. The area is equal to x times some height. And this is the part that throws some students off. The height is actually controlled by this blue line, meaning if I were to look at this point right here is x. But then what makes the output value? The output value is made by the line y equals 4 minus 1/2 x. And you might say, well, what if I move the rectangle? Well, if my rectangle was over here, wouldn't it still be touching the line? It's bounded by this, meaning it touches it. Even if my rectangle is over here, it's still intersecting the line. So if I input an x of unknown length, I'm always going to go up until I intersect the y value, which is actually this equation. So the h is the y, and the h is equal to 4 minus 1/2 x, which is what I'm going to put here. Okay, and to set up the system of equations, luckily in this case, I already have done it in terms of x. So the system of equations is right here. Okay, now to maximize it, I'm going to put it into standard form. I'm going to simply distribute it. And then I'm going to also write it in order so it's helpful. So that would be minus 1/2 x squared. So I took the x and I went over to here. And then I have plus 4x. Okay, so now I have my good old A, B, and C. And to maximize this, I need to find my vertex. And as I've mentioned in several other videos, the vertex is HK if it's in vertex form. But can you imagine putting this in vertex form? It wouldn't be super difficult because the numbers are at least even to use completing the square on this. But we're going to go ahead and stick with our word problem model, which is to use minus b over 2a and then plug it in. So in this case, I'm going to input an x value. But I'm going to output a what? And the output is always this, right? The output is this value. I'm going to output an area. Again, as we saw in another problem, I'm not going to know the length and width unless I plug stuff back in, which is going to be another question. So let's just figure out this part. This would be minus 4 minus b over 2 times 1/2. That actually works out pretty nicely because 2 times 1/2 is 1. So this comes out to negative 4. Okay, oops, it's -1/2. I just thought about this. In the real world, you should never have a negative answer. If that ever happens, and it's okay to see an occasional mistake because it's going to happen to you when you do it. If you ever get a negative real world answer, please make sure you didn't just accidentally plug in the wrong A. The A is -1/2. So A is 4. Please notice that X is 4. We don't know A yet. So to find A, we need to plug 4 back into either of these equations. So we need to find A of 4 now. And if you want to use Desmos, feel free. If you have something else in there like I do, just click on it. It'll ask you to reload. You can start over. And so we're going to do -1/2. See how it did that? See how it put it in the bottom? Make sure you get rid of that and then put it over here in a parentheses over here. Desmos is cool because you can actually see what it's thinking you mean. So you want to put it in a parentheses there, and then plus 4 times 4. And so you can see that the area is actually 8. So this is my X and this is my area. So to answer the actual question that's being asked in this problem, what is the area? The area is 8 square units, unless I put dimensions on it. It just says units. So the area is 8 square units. If it were feet, it would be feet squared. Units, if it was meters, it would be meters squared. Now that being said, what in the world are the dimensions? Remember, the dimensions are the length and the height. Again, that's a cursive L. And the length is equal to X. So in that case, that would be 4. That's what that gave me. However, the height is equal to 4 minus 1/2 X. So that means I would then have to do 4 minus 1/2 of this value, right? Which would give me my height would be 4 minus 2 or 2. And again, that then makes it make sense. Your dimensions are this room or whatever would need to be 4 by 2, which would produce the maximum area of 8 square units. Again, if this was in feet, or better yet in yards or something, it would be maximizing a room underneath of a roof line. It could also be maximizing the support of a bridge or something like that. Now, the last part of the question is, let's say I don't want to maximize. Let's say I just want you to find the area equal to 2 units. So somewhere in here, there's a 2-unit area. And I'm not talking about this one, which clearly is 2 units. I'm talking about one that intersects the line that you see. And so the way you would do that for this last problem here is you're going to take this 2 units right here, and you're just going to put it where the area is and solve it using the quadratic formula. So that means you take 2, you set it equal to the area model, which again, in this problem, we're talking about this model. The problem again is labeling everything. For students who just use X's and Y's and you don't label the function, you're going to have trouble. And this is something that a lot of students asked me when we started doing word problems. Can I just leave the X and Y and then just say the answer's units squared or feet squared? No, because you're going to have to really be careful about what you're looking at all times. So I can't use the quadratic formula yet because, of course, I have to set it up so it's equal to 0. Okay, and so I would get 0 is equal to -1/2 X squared plus 4X minus 2. Now I have an A, a B, and a C, and it's set equal to 0. The quadratic formula must be set equal to 0. So I can go back in here and I can just type it in. A equals -1/2. It's capitalized, which isn't a problem, but I don't like that. So I'm going to make it lowercase, always paying attention to what I'm typing and what I'm actually doing. So C is -2, and then I'm going to type in the quadratic formula, minus B plus square root is in the keyboard, B squared minus 4AC. I'm going to highlight the whole thing and divide by 2A, and I get one answer. I can't hit A. There we go. That is, I would have an X value of 0.5354. And then if I copy it and see if I have a negative, there might be a second one. So there actually are 2 answers. I have 2 choices for these dimensions. But you have to understand what you're actually getting here, right? So one answer is X is, oops, wrong color. One answer is X is equal to 0.535, okay? Super important to understand what we're doing. It's actually 536 if you round to 3 decimal places. And the other answer is X is equal to 7.464. 7.464. These are not the dimensions, right? The the problem asks for specifically the dimensions. This is only X. Now, the good news is X is L, right? So L is the same thing as this, 0.536. That part was easy. However, we don't know the height, right? So the height is right here. I used it in this problem. So the height is still going to be 4 minus 1/2 of X. So that means I actually need to find the height is equal to 4 minus 1/2 of 0.536 and the other one. And I'm going to do that by using Desmos. So I'm going to come into Desmos and I'm going to say, nice job, but I need to know what 4 minus 1/2 times this is. And I can, of course, just copy it if I need to. I can just copy this in here. Boom. Just make sure if you have like weirdness, you just delete it out, or you could just type it in. So I get 5 will match with 3.732. I can copy this in Desmos and then copy in the other value if I want to. If you like to copy and paste, you could also just type it if that simplifies your life. And so again, if you have any weird dollar signs, just get rid of them. And so the dimension with 5.36 is 3.732, and the dimension with 7.464 is 0.26. Now, again, what is this actually finding? So I just want to remind you that if I take this 0.535 and I take this one and I find their product, because remember, area is length times height, it's equal to 2. And if I do that for this one, if I copy this one out and I do the same thing, I will also get the value of 2, because there actually are 2 complete separate different answers. And that actually, I'll tell you why that matters. You can see they're both equal to 2. And the reason that's so important is if I am building a house or building a bridge and I need to have 2 square units to hold what have you, I have 2 different versions that I could use. Let's say that 2 square units is a closet. Well, I have 2 different ways I could make that closet, and the client would be happy with maybe one or the other. So it actually gives me 2 different versions that I could have. All right, hope this was helpful. Just a quick review. We're doing something called maximizing using constraints of the XY axis in a line. That line is actually the output, but when you're talking about area, it's actually the height or the width, depending on how you want to think about it. The length is the x-axis, so the length can just be x. But the height, again, no matter where I draw this rectangle, my height is bounded by that line, and that line is 4 minus 1/2 x. Then we just maximize it using the vertex equation. And then we also did a specific example where we set it equal to 2. Those dimensions had to then be plugged in and determined by plugging the whole thing back into Desmos. All right, I hope this was helpful, and I hope you enjoy learning about these applications. They are useful, and they make math come alive, which I think is really